Welcome to my CCNA Security version 2 lecture review. Here we're looking at Chapter 9, implementing the Cisco ASA appliances. ASAs are the adaptive security appliances. Alright, so with that said, we have three main sections: Introduction to ASAs, Configuration, and Summary. And this is going to be a little bit lengthier PowerPoint just because there's a lot of material when configuring an ASA. So upon completion, you should be able to compare ASA solutions and explain basic operations within a ASA 5505 operations. So let's dive right into topic 911, ASA solutions. The Basic ASA 5505 is a basic firewall. It provides a minimum throughput as opposed to newer models like the ASA 5506s or the ASA 5512s or 15s. Those are more modern, more complex devices. And however, you'll notice that the speed throughput is drastically different between them. However, the price between all of them is also drastically different. So with that said, the basic internet edge would be like an ASA 5525, 4555, because they're going to have more bandwidth. If we're talking enterprise data center, those are going to be higher level models like 5585s or service modules. It kind of is flexible depending on your needs. However, the price drastically goes up based off those needs. ASAs also have a virtualization component as well. You can actually do a single ASA, and from that single device have different contexts for different customers, or a singular customer with multiple departments, each having their own security profile. Like modern day equipment, there are failover or high availability options for ASAs. You can actually have an active passive, active or a active standby firewall setup as well. That way, you can always have a dedicated path leaving your network. Similar to HSRP when we're talking about routing. You have what's called identity firewalls as well that can help with identity management. So they'll integrate with an LDAP or Microsoft Active Directory or other directory services using things like Radius or TACACS. ASAs have newer modules. They have been adapted to take things like threat control. And some are built in, some are add-on cards. That makes these appliances way more flexible than a traditional router. When you're thinking firewalls, one of the big things here is looking at permitted and denied traffic. You can actually control the flow of traffic using firewalls. There are two major modes when dealing with firewalls. You have a routed mode and a transparent mode. In routed mode, things will flow through the device, and the network is aware of the device. In transparent mode, the firewall is just an add-on to the network and allows traffic to be funneled through it, but not always directly. ASAs do have some base licensing. Depending on what you want to pay for, you can get things like IPsec or encryption or licensing for a specific amount of VPN users. It really all depends on what you're looking for. Here's the base licensing, and then here's the security plus licensing. You're going to notice things like Anytime connect mobile devices, numbering may be different, or optional licenses may be higher, or trunking may be higher. Basically, with the licensing, make sure to contact Cisco's licensing specialist to get the appropriate licensing that you need to fit your organizational requirements. This is going to be different depending on the organization. How do you see what licensing you have? On an ASA device, you can issue the show version command, and it will provide you with the licensing options and how many licenses you have. Alright, moving on, let's talk about how to configure some of this. So 9.1.2 basic configuration. So when you look at a ASA 505 or 5505, you need to first of all understand what you're looking at. If you're looking at the back panel, you're looking at the lights, you're looking at the activities, you're looking at what options are there, like power, status, activity, VPN, SSC. On the front, we're looking at things like its Ethernet ports, its console ports, its USB ports, its locking ports, our power ports, and so forth. So let's talk about the security levels. So at the security level control of an ASA, there are three major types: network access, inspection, or the inspection engine, and the application filtering. It can do all three, all depending on the licensing that you have. And you can actually apply security levels on interfaces. That way you can see a trust profile or a trust level that's associated with them. Moving on about deployment. So ASA deployment in a small branch versus can be varied depending on your equipment, your setup, how you want to do certain things, if you have a DMZ, if you don't have a DMZ. So keep in mind when we're doing this, a ASA, depending on the environment size, will drastically change. As a ASA deployment in an enterprise may look more like this, with telecommunicating workers, with corporate headquarters, with multiple VLANs, and so forth. So I know we weren't really talking about basic configuration as in the command configuration portion of it, but that is our next section. Our next roundabout 55 plus slides are about the ASA firewall configuration, looking at explaining what the firewall services do, how to enable them, configuring basic functionality, configuring object groups, configuring ACLs, configuring NAT, configuring AAA, and looking at how to deal with the modular framework that's used in the policies. So the first portion is about the ASA firewall configuration. So when we're doing this, we're looking at, first of all, the different modes. User exec versus the privilege mode versus the global configuration mode, as opposed to the subconfiguration mode. We are assuming that basic iOS router commands are already known. Things like the enable secret, passwords, IP route, certain show commands are known. In an ASA, they're slightly different. So things like enabled secret is now just enable password. Looking at the line passwords, no longer do you have passwords like that, you just have the password D command. IP route is now route outside. Show commands are very similar, but here show IP route for the iOS is just show route in the ASA. Show VLAN is now show switch VLAN, and so forth. So there are different command sets between iOS devices and the ASA devices. So definitely want to spend some time getting used to the different command sets. So things like show password encrypt. If we are doing a No, actually show password encrypt will actually show you password encryption if it's enabled, if it's not enabled. You can do certain help commands in the ASAs that you could not in an iOS device. Default configuration, very similar to any other device. Enable password, setting up VLAN, setting up description on interfaces. Here you're going to notice we have security levels by default. Security level 0, that's going to be an untrusted option. You have things like NAT, HTTP or web services running on it. Here we have a DHCP addresses set for inside, and so forth. So entering the ASA setup initialization wizard, here you're going to notice normally we are not allowing the pre-configuration. So here they did a question mark. You can actually go through a lot of the basic setups through the wizard if you don't want to do it manually. How do we configure the management settings and services with a Cisco ASA device? Log into it, go to its global configuration. You should be able to set time, set dates, things of that nature. Specific commands for ASA, things like the host name, domain name, enable password, banner, key configuration, password encryption types. The password encryption type doesn't always work. Here they're doing password encryption AES. Not all ASAs will function correctly, and in the lab environment, this doesn't necessarily mean that you'll be able to get this command. I was working on one ASA, and the command worked. I had to restart the ASA, and this command would no longer work. So sometimes this command is a little bit buggy. So if we're looking at how to configure that, here we go. Host name, you need to set up your domain name, set up the password classes, set up the banner. Notice now the banner can stretch between multiple lines. And again, enabling like the AES encryption example. If we set a show password encryption, we can see that it's not saved. We can actually go in, set up the configure key password encryption, and then set up the password encryption type. That will allow us to show that we can set up AES encryption. And again, there's sometimes bugs with this, but for the most part it does work. Logical VLANs are very similar. Interface VLANs, you give it a name, we give it a security value. Set the security levels where 0 is the lowest and 100 is the highest. Keep that in mind. The security levels do matter. You can also set up IP addresses, DHCP, manual, or PPPoE, point-to-point over Ethernet. So realistically, you'd be doing manual or DHCP. Also notice here we have IP address, DHCP set route, which is used to set the interface request and install the default route for the upstream device. So that again sets us up a pathway for communication. Here we actually do the configuration on VLAN 1 and 2, setting outbound and inbound. Again, the highest level, that's going to be the more trust that it has. And again, 2 different VLANs showing how to set the security level. So now that you configured both inside and outside VLANs, you've set the security levels, set their addresses, how do we verify? Well, we can verify by doing the show switch VLANs, but don't forget, after you create the VLANs, you have to apply the VLANs. So you'll navigate to the appropriate interfaces, and you do a switch port access, and set them to the appropriate VLAN, and turn them on. And then again, double check where the VLANs are. Show switch VLAN will show you the VLANs that you have. In this case, we have 2 inside and outside, and you'll notice all ports are tied either to ETH0, which is on the outside, and all other ports are tied to the inside VLAN. And that may or may not be how you want it done. You can kind of pick and choose how you want to do that. So again, you could just show interface IP brief and it will show you all the interfaces, show you their statuses. You can verify the addresses by again show IP address, and that will show you the interfaces, the names, their current address, their methodology, or their address, their subnet, and their method, whether it be manual or DHCP, and so forth. Next, configuring static routes, just similar to an iOS device. Route outside, you put the source subnet, and you put their destination, so you can control that route. Here we're forwarding all traffic to that address, and it goes directly into the routing table. Show route will do the routing table, just like iOS will. That's going to be similar to any route command that you'd find in iOS. So moving forward, we have the ASA commands for passwords, for Telnet, for timeout. So again, we're setting up a password, we're setting up Telnet, giving it a timeout, and we are verifying it. Notice the show commands can run in the configuration option now. Again, password is setting up the password. Telnet will identify the inside host or network that can telnet to the ASA. Telnet timeout will allow the timeout sessions for idle, and you can set up a AAA method if you want. Oh, I went back. Sorry for that. So for configuring the remote access, setting up things like the username and password and SSH, the crypto key. Crypto key is similar to SSH. Version and timeout, those are all the same in iOS. The important part here is SSH. We're setting up the SSH command, setting up the internal network, and what addresses will be acceptable. Notice here for the internal networks are inside, and the external network is classified as outside. So one of the big things is when you do this, when you're setting up ASA, when you're setting up the crypto keys, what about time? Time is going to be a crucial factor here. So the next portion of setting up the ASA is actually about being able to set up NTP authentication, trusted keys, setting up the appropriate NTP server, and how you're going to authenticate between the client and server for NTP. And here are the commands to do that and how to set the server. What about DHCP? Again, DHCP is very similar to any iOS device. You can set the address ranges, you can set the inside range, you can set the lease time, and so forth. Alright, moving on, we have 923 object groups. So objects, they can be a network or a service. If we're setting up an object group, we can have network, service, user, protocols, or even an ICMP type. So we have some wiggle room here. So if we're setting up a network, an object network, we can name it, we can set up the appropriate hosts. If we are looking at the appropriate host, we can also set up ranges for that so that we can see a range of addresses. So we don't just have to have a address for a network, we can have multiple. When we are looking at services, we can set up multiple services that we want. Not just a single service, we can have multiple. And then we can actually apply these services as a destination, or as a source, or a combination. TCP or UDP, ICMP, and so forth. So what we're getting at is we can start applying groups to networks and to services so we can manipulate these, which we're going to talk about that here in just a few slides. The nice thing when working with objects, you can have them tied to security, to users, all different types of things. And here we actually have a object group for networking. We can start describing the objects. We can start showing how they work together. Here we have the object group for services. Again, groups of services. So let's go to ACLs. 924. ACL is very similar to a iOS ACL. The ASAs will use network masks, not wildcards. ACLs are always named, not numbered, and by default, interface security levels apply access control without an ACL configured. So there are some differences between the two. The big ones being named ACLs and not having a wildcard. So again, higher levels allow to lower levels. A lower level is denied to a higher level. So here, trying to go from the outside with a 0 to a higher level 50 won't happen. However, with a higher level trying to get lower, that will be acceptable. ASA ACLs will control network access via IP. They can be used for AAA rules, identify addresses for NAT, help with VPN access, and help with identifying traffic for our MPFs. Where standard ACL is for more like a routing protocol destination networks. And then again, we have our IP6 ACLs, which control network access for IP6, which again, that's all common for iOS, so moving forward. If you are not sure how to do an ACL, do a help ACL or help access -list so you can pull out the commands. Here's how you do a named ACL. Access list, name, extended, what do you want to do, its protocol, source, destination, and so forth. We have examples of these coming up. ACL ID, the action, protocol source number, the source operator, source port, destination port operator, destination port, log, and time range. Because you can actually specify a time range for the access control entry. So you can say this only applies Monday through Friday, 8 to 5, for example. Once you create the ACL, you have to apply it to an interface. That's an access group. Access group ID. How are you going to apply it in and out interface? The interface name, per user override, and if there's a control plane involved. You can have per user overrides that can ignore the ACL if applied. Here we have the ACL reference topology. You can actually place, depending on how you want to set it up, you can set up protocols for like web and email services on different servers. Actually, I take that back. Here is an example. Here are the commands. You can actually do specific items from one host or multiple hosts to multiple services and then apply them that way. Which is what that example was looking at right there. For the access list entry, again looking at that topology, here's what the command would actually look like. Creating the services, setting up the ACL for the remark and extended, and then setting up the appropriate object groups for servers, not just networks. And that's how you'd be verifying the ACL and object group. is the bottom option. Alright, moving on, 925 NAT. Just like with iOS, we have NAT commands, inside, outside, and bidirectional NAT. So how are we applying the NAT? As it's leaving, as it's entering, or is it both ways? So with dynamic NAT reference topology, here's kind of going to be our example. So with our public, we would set our range. With our dynamic NAT, again, we'd be setting a range. And then we would be referencing our public. Because again, the dynamic portion would probably be our inside. Our public would be the outside. We'd have to do a policy map for our global policy, setting up our class and inspection, setting up the access lists, and then setting and applying the access group to an interface and which direction. Here, access group, ICMP ACL in interface outside, that would be applying to the outside interface. So dynamic PAT configuration, object network inside network, that's just setting up our option. Our dynamic would be, our NAT would be dynamic interface, because that's going to be going to our, allow for our inside network access. If we were doing our verification for dynamic PAT, would be doing a show X late, and that would show our different options, showing our PAT, whether it be internal, outside, and the additional flags and times. Configuring static NAT, setting up an appropriate VLAN, naming it, setting up a security level, applying it to an interface as well. That does the configuration portion for that. Now, how to set up the static NAT? Setting up the object, setting up the host, setting up the network, applying the appropriate access list and access group, and setting up the appropriate policy maps, and then applying that map to that interface. Notice here we're doing interface DMZ. That's going to be based off the name. We can verify by doing a checks X late. I believe one of the last major sections is going to be AAA. AAA, again, who are you? What can you do? And the record keeping, authorization, authentication, and accountability or accounting. We've already looked through this, looking at radius and tag acts. Here with AAA server, we'd be setting up a server tag and the appropriate protocols. So here, AAA server, TAGAX server, protocol TAGAX. So here the server tag is just the name. Setting up the appropriate server group and hosts. Setting up the appropriate authentication for HTTP, for the different options, whether it be local, whether it not being, for serial, for SSH, for Telnet, so forth. Our last major topic is setting up the service policies on the ASA. We have to classify traffic, define the action, and activate the policy. Class maps, policy maps, service policies. Set up the appropriate ACLs, match them with the appropriate ACLs, and then that allows us to do the class mapping. Now we have to define and activate our policies. So we set up our ACL, do a class map, give it a name, match the appropriate ACLs. We have a service policy, name that as well. name a default policy. Well, at least understand the default policy so we can understand how the traffic will flow. And actually, that is the last section in this chapter. Dang, this chapter is just a really long chapter, but we are going to reinforce it with some labs. If you have any questions or concerns, please feel free to reach out. I know the policy development section was a little light. That's because in the lab portion we go over that as a reinforcement. If you have any questions, again, please feel free to reach out. I look forward to working with you. Thank you.